Welcome to the Deep Dive. Today we're taking a deep dive into all this interstellar travel research you've been doing.
Oh, it's exciting stuff.
Really fascinating. So, rockets, lasers, we're even talking warp drives.
Yes.
You've been busy. We're going to break it all down, cut through all the technical jargon, really pinpoint what everyone needs to know.
It's going to be quite a journey. We'll be exploring all the mind-boggling possibilities of actually reaching another star system.
It's incredible. Now, you've been digging deep into the science, that's for sure, with these reports, breakthrough propulsion study, and even, get this, warp field mechanics 101. Pretty ambitious. You're not just satisfied with the nearby star, huh? You're thinking bigger, the far reaches of our solar system, the Kuiper Belt, maybe even, the Oort cloud, right?
That's right. These are the frontiers that, well, they really capture the imagination.
I bet they do.
But before we get too far ahead of ourselves, we need to address the elephant in the room, or rather, the vast emptiness between us and these destinations.
You're talking about the mind-blowing distances involved in interstellar travel.
Exactly.
It's almost impossible to grasp. Voyager 1, it's zipping along at 38,000 miles per hour, right? Still would take an astounding, get this, 75,000 years to reach Proxima Centauri.
It really puts things into perspective, doesn't it?
It really does, and that's the closest star to us.
And that's just a one-way trip. Imagine launching a mission to the Kuiper Belt. With current technology, we're talking about a multi-generational voyage. And it's not just about getting there, but the immense timescales involved in transmitting data back to Earth. Imagine waiting centuries for a signal. It's daunting.
Okay, so conventional rockets are clearly not an option if we're talking about interstellar travel within our lifetimes.
Not a chance.
You've been looking into some pretty wild alternatives. Nuclear fusion rockets, giant laser-powered sails. Could these be the game changers?
They're definitely steps in the right direction. Nuclear fusion, for instance, could theoretically propel a spacecraft to a significant fraction of the speed of light, significantly faster than anything we can achieve with chemical rockets.
Harnessing the power of the stars themselves. What about these laser-powered sails? That sounds like something straight out of science fiction.
It does, doesn't it? But the idea is grounded in physics. Picture this. A powerful laser array stationed in space beaming concentrated light onto a giant, ultra-thin sail attached to a spacecraft.
Okay, I'm picturing it.
The momentum from the light itself would propel the spacecraft to incredible speeds.
That's amazing. I was reading about this project called Breakthrough Starshot that's actually exploring this concept. Yeah. Sending a tiny probe to Proxima Centauri at 20% the speed of light using this technology. It's incredible.
It certainly is ambitious, but even with these advancements, even if we manage to reach those speeds, we're still talking about decades, if not centuries, to reach even the closest stars.
Right.
And let's not forget the immense engineering challenges involved in actually building these systems.
That's what I find so fascinating about this whole thing. It's not just about the physics. It's about pushing the boundaries of engineering and what we think is even possible.
Exactly.
Building a laser array of that magnitude, it would be unlike anything humanity has ever attempted. We're talking about structures potentially larger than Earth itself, requiring resources and coordination on a scale never seen before.
Exactly. And that brings us to an even more radical question. That what if, instead of trying to brute force our way through space at incredible speeds, we found a way to manipulate the very fabric of space-time itself?
Now we're talking. You included some research on warp drives in your deep dive. This is Star Trek stuff. Are we talking science fiction, or could we actually bend space-time to our will?
It's a question that, well, it's captivated physicists and science fiction fans for years, hasn't it?
It really has.
But what's so interesting is this concept of warp drive. I mean, it's still theoretical,
right,
but it's not completely outside the realm of, of known physics.
Okay.
The most famous one, the Alcubierre drive, it comes from Einstein's general relativity.
Right.
And that's a theory that's already, revolutionized our understanding of gravity.
Okay, so break this down for me. We've all heard bending space-time, but this is different. A warp drive suggests something much more dramatic.
It does.
Are we talking about, folding space, punching holes in the universe? How does it even work in theory?
Okay, so imagine space-time is like a giant, flexible sheet, okay? And You're right, it's not just about bending it like we see with gravity.
Right.
The Alcubierre drive, what it proposes is creating a warp bubble around the spacecraft.
Okay.
And this bubble would contract space-time in front of it and expand space-time behind it.
Okay.
So the spacecraft itself wouldn't actually travel faster than light locally, see? Instead, it would ride this wave of warped space-time, effectively making the distance shorter between where it starts and its destination.
So it's less about the ship going faster than light and more about, like, manipulating the kind of cosmic road itself. Like, we're changing the speed limit of the universe, but just for this bubble.
That's a great way to put it, yeah.
That's wild.
The spacecraft inside the warp bubble, it would actually perceive itself as being at rest.
Wow.
While the bubble itself, propelled by the distortions in space-time, could theoretically travel at speeds exceeding the speed of light.
Incredible. This is incredible. But I'm guessing there's some pretty big hurdles to overcome.
Oh, absolutely.
Before we start warping space-time,
Oh, yeah.
what are the biggest challenges?
The biggest one, and it's a big one, is that it needs something called negative energy density. The Alcubierre drive, as we understand it now, needs a kind of exotic matter with negative mass to create those distortions in space-time.
Negative mass. Okay, now we're really getting into science fiction. So you're saying we need matter that acts like it has less than zero mass. Is that even possible?
It's definitely a concept that pushes the boundaries of our current understanding, that's for sure.
I bet.
It'd be like matter that, instead of attracting other matter through gravity, it actually, repels it.
Wow.
This type of exotic matter would be essential for, creating that space-time distortion effect of a warp bubble.
Okay, so not only do we have to find this bizarre, never-before-seen type of matter,
Yeah.
but then we've got to figure out how to, harness it and manipulate it with incredible precision.
Exactly.
It's daunting.
It's a huge challenge. Yeah, I mean, we haven't even observed negative mass yet, let alone figured out how to create it, contain it, or utilize it. Some physicists even question whether negative mass could even exist within the known laws of physics.
Right.
But the idea itself is incredibly exciting.
It feels like this kind of research is, pushing us to the very edge of what we know about the universe.
It really is.
Even if, warp drives never actually happen in our lifetime.
Right.
Just investigating them, just grappling with these, seemingly impossible concepts, it has to be leading to other breakthroughs.
Absolutely. It's like, imagine trying to climb a mountain that's never been climbed before.
Yeah.
Even if you don't reach the top.
Right.
The journey itself is full of, discoveries along the way.
That's a great analogy.
And in this case, we're talking about, expanding our knowledge of fundamental physics, unlocking new forms of energy, new propulsion systems, maybe even uncovering new properties of matter that we haven't even dreamed of.
I love that. And speaking of pushing boundaries, I read that there are teams out there actually doing experiments, attempting to create these tiny warp fields in the lab.
That's right. NASA's EagleWorks laboratories, they've been working with this device called a warp field interferometer, right? It's a super sensitive instrument, and it's designed to detect even the tiniest distortions in space-time.
Wow.
Think of it like a super-powered version of the Michelson-Morley interferometer. That's the one that disproved the existence of the luminiferous ether, remember, back in the late 19th century.
It's amazing, really, that we're even at a point where we could try to measure something like that.
Incredible.
It really highlights how far we've come, even if a warp drive, like a real one, is still a long way off.
Right.
So where do we go from here? Are we stuck in this solar system for the foreseeable future? Or is there a way, a real way, to get to those distant stars, within a human lifetime?
Well, I think that's the question that drives all of this research, isn't it?
It really is.
And while we don't have a definitive answer just yet, the journey itself is, it's already full of incredible possibilities.
That's true.
Think about it. I mean, we've gone from these basic chemical rockets to actually thinking about manipulating space-time itself.
I know, in just a few generations.
And it's remarkable.
Yeah, it's remarkable.
Who knows what the next big scientific discovery will be?
You're right, who knows? Now, you mentioned earlier that some scientists, they envision this multi-stage approach to interstellar travel.
Right.
We've got this era of precursors, right? Mm-hmm. Where we're just dipping our toes into the interstellar ocean with probes like Voyager.
Right, like our scouts.
Exactly. And then there's the era of infrastructure, where we're actually laying the groundwork for these more ambitious missions, right?
Exactly, building the foundation.
And then finally, the era of breakthroughs, where these seemingly impossible technologies like warp drives might actually become real.
Imagine that.
Where do you see us on this timeline, right now?
Well, right now, we're definitely living in the era of precursors, wouldn't you say?
Definitely, yeah.
Voyager 1 and 2, New Horizons, they're giving us such valuable data about what the interstellar environment is actually like.
It's amazing.
They really are scouts, venturing out into uncharted territory.
Exactly.
And sending back these incredible glimpses of what's out there beyond what we know.
It's incredible. And at the same time, we're starting to see these hints of the infrastructure era emerging.
Oh, absolutely.
Projects like Breakthrough Starshot, with this ambitious goal of sending a light sail to Proxima Centauri, it just shows, a growing commitment to, really pushing those boundaries of what's possible.
It's an exciting time for sure.
It is. And it's not just about propulsion, is it?
Yeah.
I mean, we also have to figure out how to keep humans alive in space for these long, long journeys.
That's right. It's a huge challenge.
We're talking life support, radiation shielding, even figuring out how to create these closed-loop ecosystems, right?
Exactly. Interstellar travel isn't just about, building a faster spaceship. It's about, completely rethinking how we interact with our environment.
That's a great point.
It's about pushing the limits of human ingenuity on all fronts.
It really is.
And all this research that's happening right now in fields like, synthetic biology, advanced materials, even artificial intelligence.
Right.
It's all going to play a part in shaping the future of space exploration.
I love that. It seems pretty clear that getting to the stars, it's not going to be like one big eureka moment.
Yeah.
It's going to be the series of smaller breakthroughs.
Small victories.
Exactly. Each one building on the last, right?
Building up to something amazing.
It's a long game, for sure. It needs consistent investment. We need people working together from all over the world.
Global collaboration. Absolutely.
And of course, we need that adventurous spirit, the one that's always driven humanity forward.
We wouldn't be here without it, would we?
Not at all. Now, after this deep dive into interstellar travel, after exploring all these incredible concepts, what's your main takeaway? What has you most excited about the future of space exploration?
For me, it's really the audacity of it all.
The audacity.
That we, as humans who came from this tiny planet, are even thinking about reaching other star systems.
It's incredible.
It speaks volumes about just how much potential we have as a species.
It really does.
And the challenges are huge, we know that. But the potential rewards are even bigger, right?
They are big.
The knowledge we're gaining, the technologies we're developing, just the inspiration we get from all of this. It's going to shape humanity's future in ways we can't even imagine yet.
I love that. It's a future full of possibilities. I, for one, am so excited to see what happens.
Me too.
Well, thank you so much for joining us on this deep dive into the incredible world of interstellar travel.
It's been my pleasure.
It's a journey that's just beginning, folks, and we can't wait to see where it takes us.